good day. I want to go ahead and spend a few minutes just doing the exam review. I downloaded this file from, I guess I can just show you real quick where I downloaded it from. On the modules page, if you go to the exam one module, the exam one overview, and I've downloaded the practice problems here, and I'm going to then be reviewing the solutions with you. So let's go ahead and get started. So there are no problems for chapter 1, but there are some problems for chapter 2 and chapter 3. So let's go ahead and take a look at those. Just give me a second while I get set up. Okay, so at the top of the page here, we start with the chapter 2 problems. And we've got this financial data for a company, and we've got outputs of in dollars, 200,000 for last year and 220,000 for this year. And then we have inputs also in dollars for labor, raw materials, energy, capital, and other. So it says calculate the total productivity measure for this company for both years. So when we do that, basically we're taking total productivity, and we just need to remember productivity is output over input. So for last year, we're going to be taking the $200,000 sales and dividing it by the sum of all of the inputs. Okay. And so via magic math, I'm going to just go ahead and copy and paste in so you don't have to watch me type, but basically that's 200,000 divided by everything added up here, which gets us to 1.64 by the time that we divide that out. And then same thing for this year's in productivity. It's also outputs over inputs. And so it's going to be the $220,000 divided by the sum of the 40,000 in labor, the 45,000 in raw materials, the 6,000 in energy, the 50,000 in capital, and the 3,000 in other, right? And so the total productivity for this year is 1.53. So while we had more sales, right, our productivity was actually lower. And if we kind of compare across, we can see we were a little bit higher on energy. We were quite a bit higher on labor, and raw materials were also higher. So again, if we were trying to assess that, now I'm not going to ask you to assess it on the exam. I'm just going to ask you to calculate it. Okay. And then it says calculate the partial productivity measures for labor, capital, and raw materials for this company for both years. Okay. Well, to do that, you have to remember that partial productivity only involves one input. So basically it's asking us to calculate 3 productivity measures for each year. And so when we do that, we do outputs over inputs for labor, capital, and raw materials. And I'm just going to copy in a table to show you what that looks like. And again, we take the 200,000 divided by 30,000 to get 6.67, 200 divided by 50 for 4. So again, the thing to remember is that partial productivity is outputs over one input, not to be confused with multi-factor productivity, which is multiple inputs, but not all. Okay. So if I were going to explain this, I would say that total productivity is inputs divided by, is output divided by all inputs. Partial productivity is output divided by one input, and multi-factor productivity is output divided by more than one input, but not all inputs. So it could be something like labor and capital, or labor and raw materials, right? But it's not all of the inputs. So that's something you're going to want to remember to be able to distinguish the difference there. All right. So the second kind of set of questions we want to hit here is a parcel delivery company delivered 103,000 packages last year when its average employment was 84 drivers. This year, the firm handled 112,000 deliveries with 96 drivers. What was the percentage change productivity over the last 2 years? Well, for this one, we have to calculate the productivity for last year and the productivity for this year, and then we have to figure the change. Okay, so that looks like productivity for last year. I can go ahead and label that, right, is output over input, which is 103,000 divided by 84, and productivity for this year is 112,000 divided by 96. To get the percentage change, right, what we want to do is we want to take the most recent productivity and subtract off the older productivity and divide it by the older productivity. And we do that because, think about it this way. When I do the most recent, so if this year's productivity is 200 and last year's productivity is 100, that means that I'm going to have a positive 100 change. And that's what we want to show, that positive, because 200 is greater than 100. So for this year, it's better than last year. Now, if this year was 100 and last year was 200, 100 minus 200 is a negative 100. So that would then be that we have a negative change in our productivity, right? And so we want to make sure we do it in that order so that our sign works out correctly. Okay, and then after I do the subtraction, I divide it by the older productivity, and then that gives me my percentage change. All right. All right, this is just like one that you did in your homework, right? And so basically you need to calculate the individual monthly productivities and then average them. Okay, and I'm not going to spend a lot of time typing that out. I'm just going to show you how we calculate January's, February's, March's, and April's productivities, sum them up, divide by 4, right? And that gives us the average of 1.64 units per machine hour. Okay, now we move on to chapter 3. And so in chapter 3, we want to do a simple moving average, right? You all should remember that that's just basically it's just averaging the values that you have, right? And so to do that, I add up the 130, 110, 160 and divide by 3. The next one says, let's do a weighted moving average. And we want to, our years are 2011 is 130, 2012, 110, and 2013 is 160. What is the weighted moving average for 2014 if the weights are 25%, 25%, and 50% for years 2011 through 2013, respectively? Well, I take the 130 from 2011 times 25%, 110 from 2012 times 25%, and 160 from 2013 times 50%, and then add those values up to get my forecast. So that's just a weighted moving average. Okay, so as a consultant, we've been asked to generate a unit demand forecast for a product for year 2014 using exponential smoothing. Now, I will give you a formula for exponential smoothing, but if you, this is going to be simple exponential smoothing. So our forecast for the time period that we're trying to look at is our forecast from the previous time period times an alpha times the actual from the previous time period minus the forecast from the previous time period, right? And so when we finish that out, that's going to be, if we look here, the actual demand in year 2013 was 750. The forecast was 960. So this is going to be 960. Sorry, this should be a plus sign here. 960 plus my alpha of 0.3, right, times my actual of 760 minus my forecast, right? And so when I finish that out, that's going to be 897. Looks like, I'm sorry, this should be 750 here instead of Okay, so it's 960 plus 0.3 times 750 minus 960 gives us 897. Okay, the next one says, given the following time series regression, y is equal to 25 plus 2t. For every 1 unit change in time, the forecast will increase by how many units? Well, what we know about that is that our forecast should increase by the slope. So I can say that it's going to increase by 2 units for every 1 unit increase in time. Okay, so then it says, now tell me, if I'm trying to forecast for time period 10, right, what is the forecast going to be? So I can quickly show you, that's just a plug and play into the formula. Sorry, I didn't really want to. And so our formula again is y is equal to 25 plus 2 times 10 gives us 45. So that would be our forecast. Okay. A company hires us to do a linear regression forecast based on the company's historical sales information. We determine the intercept value of the model is 8,400. The slope value is minus 100. That's important to pay attention to this minus. If after developing the model, you're given a value of x is equal to 10, please calculate the resulting forecast value using this model. Okay, so again, this is just going to be using the formula for regression, which is y is equal to intercept plus slope times x, right? And so basically then we're going to say y is equal to 8,400 plus minus 100 times x. And so then we plug and play into that. 8,400 minus 100 times 10 gives us 8,400 minus 1,000. So our forecast is 7,400. Okay, the next one says, given a running sum of forecast errors of 1,000 and a MAD of 100, what's the tracking signal? Okay, you'll have an equation sheet that tells you that the tracking signal is the running sum of forecast errors divided by MAD. So basically then that's going to be 1,000 divided by 100 gives us a tracking signal of 10. Okay. And then given actual demand of 1,000, 1,100, and 1,300 in 3 consecutive time periods and forecasts for the same time periods of 900, 1,200, and 1,200, what is the MAD? Okay, so if our error is actual minus forecast, in fact, I might just do this in a table. It might be a little bit easier for you to see in a table. So I'm going to need the, let's see, label it. I'm going to need the actual, I'm going to need the forecast, I'm going to need the error, and I'm going to need the absolute error. Okay, so let's do so actual 1,000, 1,100, and 1,300. Forecast 900, 1,200, and 1,200. My error is actual minus forecast. So 1,000 minus 900 is 100. 1,100 minus 1,200 is minus 100, right? And 1,300 minus 1,200 is 100. So my absolute error is 100, 100, and 100. And so then it's pretty easy to see in this example, my MAD is going to be 100 because the average of those three values is going to be 100. Okay. So that does it. That's our kind of review of the types of problems that you're going to see. Just a quick reminder that if you show me your work, I can give you partial credit. If you don't show me your work, you'll either get all the points or none of the points. Hope that helps.